Yes, hello friends. So this is the video tutorial for today's lead code problem today, which is 1590, make sum divisible by b. So let's read through the question first. Given an array of positive numbers nums, remove the smallest subarray. Smallest is defined by the size here, not the the sum, possibly empty, such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. Yeah, it is also mentioned here. Okay, return the length of the smallest subarray that you need to remove, or minus one if it is impossible. So a subarray, we all know what a subarray is, and the constraints are that n is around n is to 5, where num size is around n is to 9. Okay, that's fine. So let's reuse the first test question 3142 with p equals to 6. Okay, so the first test case is 3, 1, 4, 2, and p equals to 6. So what's the sum of the array? Here the sum of the array is 3 plus 1, 4, 4 plus 4, 8, 8 plus 2 is 10, right? So 10, and we want 10 divisible by 6. Now this 10 divisible by 6, what we'll get as remainder here? So see, this is not divisible, we 4. So we should remove a sum, or rather a subarray, which has a sum mod p equals to, or rather the subarray sum equals to total sum. So this is the subarray sum, and this is the total sum mod p. So these two should be equal, right? So the idea is that we should remove a subarray of sum which has this property, that sum mod 4 is equals to the sum mod p is equals to total sum mod p. Here total sum mod p is 4, so our sum of the subarray mod p or mod 6 should be 4. So what is the subarray here which has a mod p? So one's choice is this. You see 3 plus 1 is 4, and 4 mod 6 is 4, right? If we remove this, the rest of the sum would become 4 plus 2 equals to 6. 6 mod 6 is 0, and it becomes divisible. Okay, so this is fine. This is one choice. Is there a better choice? So the choices are based on the size. So this has a size of 2. Another choice is just remove this 4, right? So 4 mod 6 equals to 4, and this also removes this remainder extra. So what's the problem here is that total sum is 10. We When we divide 10 by 6, we have a remainder of 4, right? We have 4 extra elements, we should remove this. 4 extra sum, we should remove this. So this is a better choice. Why is this a better choice? Because this only removes one length of the subarray is 1, so we want to minimize this. Okay, that is fine. But okay, so we were able to understand the first test case. How can we generalize it, or how can we use code of this? So the property that we were able to see is that sub array sum mod p should be equals to total sum mod p, right? Now whenever we are dealing with subarray sum, we should always come to prefix sum, obviously. So let's say the subarray is from I to j. So what would be a prefix sum, or the subarray sum in prefix sum would be prefix sum of j minus prefix sum of i, I minus 1, right? I minus 1. Okay, I minus 1. So the total sum till here minus the total sum till here, I minus 1. So if the sum till here is 100 and the sum till here is 20, what would be the sum from I to j? That would be 100 minus 20, obviously. It, right? So PS prefix sum of j minus prefix sum of I minus 1, where these are the j and I minus 1. Mod p should be equals to total sum mod p. Let's say total sum mod p some y value, right? Okay. Now let's say we know our I. So our I is fixed. Now we want to find the j, right? So what would be the value of prefix sum of j? It would be what? Y plus prefix sum of I minus 1 mod p. Or rather, prefix sum j mod p. Because see, we are doing this mod p here, and then we are moving this ps I minus 1 mod p to the RHS. So prefix sum j mod p should be equals to this thing. Now this y we know, this is just total sum mod p. This prefix sum I minus 1, we'll iterate over I, so we'll know this prefix sum I minus 1. We also know a p that is given to us. So from here we can get this thing, prefix sum j mod p. Now, if let's say prefix sum j mod p for a given I here, we have we need prefix sum j mod p as some 10 value. Now let's say prefix sum j mod p occurs at 3 indexes. So at 3 indexes, let's say it occurs from I, let's say I is some 3. So it occurs at 3 indexes. It occurs at 5, it occurs at 7, it occurs at 11. Now which of them should we pick at 3? If we are at 3, we want the minimum of these, right? We want the minimum such period. So minimum of j, because see, we want to minimize this length, and length would be what, j minus I plus 1. I is fixed, so we should minimize our j. So we will pick only this 5 one. The 7 and 11 are not optimal, right? So we'll have a map. We are at I, and we'll have a map or an unordered map, anything that will store that for this prefix sum j mod p, what is the last index, or what is the, like, we'll traverse from back, and then we can keep like what is the last index I. So we are at I, so we'll have this j, which is the last index, such that this value, the required value, let's call this rec. This is the required value, right? What is so map of rec? And let's call this MP. So MP of rec would have, if see this was never, we were never able to get this required value. So this required here was 10, right? So map of rec, if this rec key is in map, so we'll have the last index that this occurred, so, like this index. If it occurred here, we'll overwrite it when we were going here. So, and then we can get this and see if at none of these things that rec was never in the map, then the answer would be minus 1. Else the answer would be the minimum of this j minus I plus j minus I plus. Yeah, let's show you the code here. So yeah, hopefully you were able to understand something like how we can use prefix sum to get this. So yeah, what I did is just using LL here as long because we are dealing with sums, and sum can go very large, or go over the limit of integers. So I create this prefix sum array, and yeah, I just store that prefix sum of I is num I plus prefix sum of I minus 1. If I minus 1 is 0, then we'll just add 0 here. Then this total sum, now we'll have to check if total sum mod p is 0. So the array is already, the sum is already divisible by p. We do not need to remove anything, we just return 0. Now, as I said, in this way, we'll store this total sum mod p, and answer is basically the length of the minimum that we have found till now. So we have created this unordered map. This unordered map is basically that MP of rec is the last index that we were able to get this, or this thing. This basically prefix sum of j mod p that will calculate at this I index. Okay. So we go from back to forward. Why back to forward? Because see, at I we need the next most index in j, right? If we wanted that, if we went forward, then we'll not have the information of the next. See, and now you're at I, we want the what should we say, we want the information about j which is after it, right? Because see, this is at I, this is at j, we are the prefix sum of j minus prefix sum of I, right? I minus 1. So we, this j has to occur after I. That is why we are traversing backwards. So when we are at I, we will already have information for all of these j that are after I, right? So yeah, we'll traverse backwards. I create this x equals to px I mod p, and I update map x equals to I. So at basically this is this at psj mod p, right? So what are the all the, if we see like see what we will do when we are at 11. I saw prefix sum j mod p value is 10, right? So at 11 I will add that mp of 10 equals to 11. Then when we come to 7, then again mp of 10 would become 7. This would be reduced. Then at 5 this would again reduce. So well, in this map we are just storing the what is the last index that we have seen this. That is what I'm doing here first. Now I calculate my required. Required is y plus ps I minus 1 mod p, right? As we calculated here. So yeah, I calculate my rec. I check if this rec is in my map. If it is in my map, I get my x j. This is the last index that this occurred. I store this in answer. Answer equals to minimum of answer j minus I plus 1. And then finally, we have to check this thing that we are not removing the whole array. So if answer is greater than equals to n, that is we are removing the whole array to make it divisible by p. Because see, 0 is divisible by p. If we remove whole of the array, then we'll have left 0, and 0 is divisible by everything. So then it would become, but the question clearly says that it is not allowed to remove the whole array. So I will have check this answer is greater than n. If it is greater than n, we'll return minus 1, else we'll just return answer. Yeah, this works. Thanks for watching. Hopefully you were able to understand something. Bye bye. Leave a like and subscribe, all of those things.